Guys, okay, so I want to go over the guided practice. I know I've gotten a lot of emails. I'm sure other teachers have gotten a lot of emails as well. Mostly the problem that people are having is with that bottom DNA replication part. I want to make sure we get that down because we want to be able to do the model and be able to accurately transcribe or copy over, replicate the DNA. Okay, so let's go ahead and look at the worksheet, which is here. All right, so I don't really think I need to go over all of these. Some of these were opener questions. The nucleotide is your base, your sugar, your phosphate. Adenine pairs with thymine, cytosine pairs with guanine, and hydrogen bonds hold those two strands together. And the backbone is the sugar phosphate molecules together. The bond that they create is that backbone. Phosphates in one group bond to the sugars of the next group as if you move up the ladder. And Chargaff's rule, if you were not paying attention to the notes or classwork, and hopefully you realize A pairs with T, so adenine and thymine bond together, and they are equal amounts of each other because they bond together. And then cytosine and guanine are also bonded together, and they are in equal amounts as well. Number 8 here is a bit more of a mathy type question, but it's not too difficult if you think about it. So if we have 30% of a strand of DNA is adenine. If A equals T, then how much thymine would we have? And that would be 30%. So then your A is 30%. So let's just go ahead and write this in here. So A equals 30, and then T equals 30%, which means 100% minus 30 minus 30, so minus 60% equals 40%. So that's how much we have left to deal with. Must B, C, and G combined, okay? So then we take 40% and divide it by 2, and that's going to equal 20% for cytosine, and then 20% for guanine. Okay, you don't have to do all the math or show all those steps, but I just wanted to walk you through how to make that calculation. That's going to be helpful for homework number 3, where we are going to be making calculations for several different combinations. Hopefully, for number 9, you got that it's a double helix. Okay, first step is DNA unwinds, so B. The second step is the daughter strands. The DNA of the daughter strands is A, and then the third step is C, so BAC. Why, for number 13, is DNA called semi-conservative? So hopefully you saw that the parent DNA, or the original strand, 1/2 goes into your new strand, and 1/2 is new. If you have half original and half new, that means it's semi-conservative. If you had all original like this would be conservative. I don't know how you would do that, but you know, I guess it's possible in some weird way, maybe, I don't know. And then number 14 is which enzyme connects the new bases to the old bases, and that's DNA polymerase. And which enzyme connects the nucleotides together and proofreads them? The proofreading is done by DNA polymerase. And then number 16, once the DNA has been copied, the S phase is complete. The cell is now ready to move on in the cell cycle. Which phase is next after we have S phase? So if you remember, the cell cycle starts with G1, it grows, then it hits the S phase, your DNA is synthesized, then it moves into G2. So hopefully you got G2 from this. I'm going to erase that real quick before I forget. Okay, so let's look at using the base pairing rules, which was A equals T and C equals G, to create the complementary strands. What I would like to do is number these. Like if you want to think of it this way, this is column 1, column 2, column 3, column 4, column 5, and column 6. We are taking all the information in column 1 and copying it into column 3. Okay, so I'm just going to cheat a little bit here and copy and paste that in. Okay, then we're going to take all of this information in column 2 and paste it into column 6. Okay, Control C, Control V. Okay, then I need to make sure, because it's our parent DNA, we're going to highlight it. And since I like purple, we're going to do purple. And I did the wrong thing. Control Z. Let's try. Oh, it's the fill button. I forgot. Purple and purple. Okay, so that's our parent DNA. Then we're going to make the new strand. Okay, so A bonds with, and I'm going to put my caps lock on, T, oops. C bonds with G, T bonds with A bonds with T, C bonds with G, G bonds with C, C with G, G with C, A with T, T with A, okay? Then we're going to get this one, and we have A bonds with T, because we're looking at the parent strand here. C bonds with G, T again, A bonds with T, C bonds with G, G bonds with C, C bonds with G, G with C, A with T, and T with A. And that's all you have to do for that one. So hopefully you also noticed that these three columns, or these three main strands, are all identical because it's replicating, it's duplicating itself. It's not creating anything different or anything new. It's making an exact copy of itself. So hopefully you saw that. Okay, one strand will turn into two more identical strands. And this half is original and this half is original. Okay, please, please, please practice this on your own some more. And if you do have any questions, email me and I'll be happy to answer them. Or better yet, come to pause. I'm always there. There's very rarely people in there with me. Okay, have a great rest of your day.